All right. So I know you are super excited to get back into linear regression, and I'm really sorry that I couldn't be there to share in the absolute joy that you're going to experience by doing this without me. So hopefully this will come back faster than not. Um, if you if you need me to go back over it again, we can talk about it. But for the most part, it's going to be relatively straightforward. Let's talk about what we're going to be doing today. The goal here today is really to review the basics of all of our linear regression stuff. So, like correlation, things that we talked about in terms of like slope and y-intercept, r and r squared, residuals and residual plots. Although the residuals will not take as much of a big role in this chapter, everything else will kind of come back from what it used to be. So the first thing you see here is we have a set of data that is essentially a student number attached to their anxiety level and their score on a math test. The question is, does anxiety and math have a certain relationship? Some of you will agree that this is a true statement. Some of you may not. Let's see what the data says. Ultimately, what I want to do is take a minute, if you haven't already done this, and take your paper and go through an anxiety level. Let's put that in L1, and let's put math test in L2. So our x coordinate, our x variable is going to be anxiety, because we would say that anxiety is the explanatory of your grade on the test, right? Higher anxiety would result in possibly lower math tests, different things like that. So there's a relationship that makes sense. So explanatory response relationship happening here. But remember, that's not a requirement to do correlation. So we can do correlation between all sorts of things. They don't need to have that specific relationship that we kind of talk about. So take a minute, plug those in, and then we'll kind of come back and talk about the rest of this stuff. Okay, first things first, we're going to talk about creating a scatter plot and looking at that in the calculator, as well as kind of making it our own. So obviously I'm not going to draw the scatter plot here, but you can see that on your coordinate graph on your calculator. And so remember, to do that, we're going to go, you're going to plot it into L1 and L2 first. Then you're going to go second y equals, hit enter on plot 1. Remember that the scatter plot is the very first graph you see, so make sure that you selected that first graph, and make sure that your x list and your y list are the ones that you were using. I used L1 and L2. Make sure that you're using the correct ones. At this point, it might be a good idea to go into your other statistical plots and make sure that those are off. If you have multiple graphing at the same time, you could definitely generate an error, and it would give you a problem with that. So check those real quick. All right, what we're going to do next, once we've got it in our calculator, what we want to do is we want to describe the distribution, right? If you remember, when we talk about describing distributions, it's strength, direction, form, and then anything unusual that we can observe that happens in the graph. And so in this case, we can see that there is a negative relationship. The graph, when you talk about strength, that's how close to a straight line there are, right? You can see here, remember we had weak when we between 0 and 0.3 for R. 0.3 to 0.7 is that moderate range, and then 0.7 to 1.0 is that strong range. And that could also be negative, but strength doesn't require negative or positive. That's kind of what the direction looks like. In this case, we think it has a negative direction. It's moderately weak, right? So on the weak end of moderate, and we don't think there's a curve to this pattern, so we would say that it's mostly linear. I don't really notice too many outliers in this group, so we can kind of talk about that. Let's talk about the statistics we can get from two lists. If you go in and you calculate your linreg, to get to linreg, remember you're going to hit stat, you're going to go right, you're going to go down to 8, or you can hit the 8 key, and that's going to bring up your linreg. Now, when we're dealing with linreg, At this point, I don't really want to do a whole lot with it, but when you type in your linreg components, you've got to remember to make sure that you're using the correct lists in your L1 and L2. And so frequency list, make sure that that's just not there. All right, we won't be using that at all. The store regression EQ, remember to graph your line. Now, I don't need it for this part, but just to remind you, it's going to be vars, right, enter, enter. That should bring you up Y1 in your equation or in that store regression EQ. Now, if I want to graph that, then that's fine, but that's not really needed unless you're going to be doing some graphing. But you can go ahead and you can hit calculate, and what that'll generate should be 4 different numbers. You should have A, B, R squared, and R. What if you don't have all 4 numbers? Glad you asked. Okay, now press mode. That's the second button on the top row, and then go down until you see stat diagnostics and make sure that that is on. If it is on, you will see all 4 numbers. If you reset your calculator, if you let it die all the way down to till it didn't have anything left, it is possible that you have those things turned off just because you reset your calculator. So once we get those things done, go back and do linreg again if you didn't before. You can see all the different numbers. And what we want to know for this question is what R is. R, in this case, is negative 0.52. So really could have gotten away with saying it's a negative moderate relationship. The moderate to weak was, my eyes thought it was weaker than it really was. And so be careful. That would not get you any points taken off, but it's just saying what you could do. Okay, so in this case, when we talk about correlation, correlation tells us 2 specific things. The sign tells us the direction, that's positive or negative. The value, the actual decimal point, tells us the strength, whether it's moderate, whether it's weak, or whether it's strong. Now, if you remember, the correlation coefficient is the name for R. If we look at R squared, that's called the coefficient of determination. And we had a little script that we memorized for this part. R squared, in this case, if you square negative 0.52, that gives you 27.6%. We always refer to R squared in percentages. And here's this script written for this context. 27.6% of the variation in the test scores, that's the Y variable, can be explained by the variation in the anxiety level, which is your X coordinate. Now, if you kind of look at that in its context, without context, it's the R squared percent of the variation in the Y can be explained by the variation in the X. Remember, if you've got these notes, I would for sure go back and pull those up a little bit. You'll be able to kind of get a lot more explanation for these things and have it ready to go. Now, in a lot of cases, they will ask you for, quote, the linear model. What they mean by that is just the line of best fit. So when you did linreg, 2 of those expressions that you got were A and B, your line of best fits y-intercept and your slope. In this case, the y-intercept was 91.66 right here. And then the slope was negative 4.49. Now notice I don't have X and Y. I have the actual variables written into the equation. That's a great idea. If you don't do that in some instances, they will take off points for not defining your variables. Now, if we keep on going, right, the next part is the linear model appropriate or not? Now, this is where you had to check our assumptions and our conditions, right? A couple things here is we don't want to see a pattern in the residual plot. So let's go back a minute. Let's talk about residual plots. Now, in this case, to create a residual plot like this, you're going to use your y1 second y equals and pull up that plot 1, hit enter on plot 1, and you're going to change the y list in this case from your L1 is an X, your L2 should be L2 from our previous example. However, what we want to do is we want to change that to the residual plot. Okay, so go down to X or your Y list, press second stat. That'll bring up your lists. You'll scroll down and you'll find the resid list there. Now, if you haven't got the resid list in the L, like in your view, don't worry about that. We'll get to that later, but you should be able to find it from your stat list. Now, when we do that, you can hit zoom 9 and you should see a graph that looks, a good graph that we want to see looks like this, where it has no pattern. It's all nice and scattered. We don't see any kind of linear shapes. Here, this is bad. This is your nonlinear pattern. The question is linear appropriate? This is the kind of pattern that tells me linearity is not appropriate because there's a specific curve to the pattern to it. We talked about another kind, and we'll get into that for sure, but for this one, it's just asking about linearity. Okay, let's go back in and talk about slope and y-intercept. Again, this is just bringing up the stuff that we talked about in the original time we looked at this. It's these scripts. Your slope here is negative 4.49. We've got a script for each additional, in this case, x variable. We would expect the y variable to change by the slope. So in this case, in this context, it's for each additional level of anxiety, we would expect the test score to drop by 4.49 points on average. Now, the word drop here is simply describing the shape. No, sorry, not the shape. Describing the sign of your slope, because it's negative, it's inversely related, right? So as anxiety goes up and test scores go down. So I'm talking about a negative relationship. If it's positive, you could say they both go up together. The y-intercept, now this one was really a little bit not specific to a script necessarily, but you did have to remember how to put it in context of the problem. So your y-intercept here was 91.66. What that means is if x is 0, then that's what y would be. So in context, it means if I do not have anxiety, if my anxiety level were 0, then I would expect to make about a 91.66 or about a 92 on the test. And definitely don't round those. Leave them as decimal points. They're estimations. They're not supposed to be specific. And then the last question here is, does this prove anxiety interferes with student performance? And our favorite saying is no. Correlation does not equal causation. We can show association, that if anxiety level goes up, we can also show that test scores tend to drop. But there are all sorts of other lurking variables in this example where that might be also causing something to happen, and we're not really monitoring that. This is definitely not a controlled experiment. We're simply observing what happens, and because there is no manipulated variable, there's no control, there's no randomization of subjects to treatments. This is not an experiment, and therefore cause and effect, or proving something happens based on certain variables, is not even on the table. Hopefully that made sense to you. Hopefully that wasn't too crazy of a review. If you need to go back over again, you can rewatch that. We'll talk about the back of that tomorrow. That's actually on the new stuff. So take notes over the LinReg stuff, write down some formulas. There's a lot of stuff happening here. This is one of the longest significance tests, and we'll get to that soon. But hopefully this review helped.